Hi, I'm Paul Brodie. Welcome back. Thanks for tuning in. Mitch behind the cameras. It's giraffe bike time. Apparently, some of you like watching things made out of bronze and the old style of machining, so we'll get into that for sure. I got the Freewheel all finished. I had to turn down the heads. That was a little bit of a trick. I had to use a chuck inside a chuck and a file. So it's all done now. You can see how it's not the same spacing because there's 14 teeth on the sprocket inside. So there it is. It works really well. Last episode, I was thinking this was a master link, but it sure didn't look like a master link because it doesn't look like the master links that I'm used to. And we even went over, it's kind of crazy, but we even went over to the ArborPress and tried to press the link out. Well, let me show you how it works. There was a couple of viewers who wrote in, and thank you very much for doing that. Do you see how this one's flat or straight? And this one it's got a wasted section. That's because this one has the spring. And look how easy it is to take the link off. Look at that. That's all it is. So thank you for writing in. And I got a lot of bicycles, but I do not have a master link like that. So that's a new one. I worked on the bronze, which I'm going to use on the crank arms. And you can see the photo Mitch is going to show you. I hacksawed off. This is how large it was. That's just how it comes. It's 2 inches and I needed to take off 1/2 inch. So I went to the bandsaw and I had a 2x4 that I pressed against. Each of these cuts took almost an hour, and my blade is fairly sharp, and it just doesn't cut very well. This is really interesting stuff to work with. I'll tell you what it's made of. I've got it, there it is, I got it right here. So it's 954 bronze, 85% copper, 4% iron, 11% aluminum. It's got a tensile strength of 85,000 psi, which puts it up at a level of chromoly. It's quite amazing stuff. So after I'd hacksawed it, I put it into the mill, into the milling machine, and I used a face mill. That's what the face mill looks like, and that's how I took off some cuts. So I've got it down to size. I faced off an end because what we have to do, we're going to drill a hole for the axle to go through. It's the bottom bracket axle. It's basically 3/4 of an inch. It's stainless steel, and you can see how it fits in over here. I've got the bearings in there already. That's a good fit. Mitch is smiling. He knows when it's a good fit. So what's going to happen is, if you look at the drawing here, you can see there's a 3/4 inch hole, and then there's a hole coming down here, and that's for the cotter pin, and that's something else we have to make. I'm going to make a cotter pin. That's what the cotter pin looks like, and it came off the crank which was used on the whippet. So here is the crank. This is all different. See, adjustable length for the crank. This is a very old antique pedal, and this is where that goes, and there's a flat it goes in the other way, it goes in this way. I can tell because there's the mark from the, see how it fits in there? And the taper locks onto the shaft. I need to mill a flat. It needs to go down 1/8 of an inch, so I think I can do that too. And something else that's going to happen, a lot of talking, aside from a lot of talking. So you see, this is the axle. I have to make some kind of a spacer, and I think it's going to get silver soldered on. Remember how this got silver soldered on? You can actually see the silver. There's a fine line of silver around there. I think this is going to get silver soldered as well, and then I'll probably have to get it all plated. On the chrome plating, it's a little rough, and then on this side here, well, it's actually coming off here. So have to do that. So the first thing we're going to do, I think, is go to the lathe, and we're going to machine. Do you see how this is made? This is off center. It has to be off center because of the flat. This is one made a long time ago, maybe a decade ago. It's stainless steel 304, and I made this one yesterday. Can you see how it's offset? It has to be offset. And how you offset it, it took some aluminum. At first I thought 1/8 inch would work, but this is 80 thou, and that's how it's a 3-jaw chuck, 1, 2, 3, and it offsets it just the right amount that you can turn this down. So let's go to the lathe, and we're going to make one of these. If you look here, there's that 80 thou shim. Can you see that? So I got the 3 jaws, and the 80 thou shim is just under one of the jaws. And when I switch it on, watch how this OD of this is 7/16, and I need to put on a 5/16 thread. So we're going to turn this down, we're going to change the bit, change all the settings on the lathe. We're going to make a thread. I'm going to use an indicator here because that's a shoulder, and I don't want to hit the shoulder, so I'm going to set up an indicator here, and then I can thread almost up to the shoulder. I'm lifting up this lever here, and I'm snapping this. When that goes to 0, that's when I do it, because otherwise the tool will crash into the shoulder. So here we go. So not bad. I'm almost at the 0, and I didn't hit the shoulder, and you can see that I'm threading now. This is the time when you take a thread gauge and you check the thread. You want to make sure that you put the levers on the lathe in the right position. Looks like often I put a red felt pen on there so that when I make the first cut, it's easier to see, but I'm confident I got the right amount. So I'm taking off another 4 thou. There we go. It's got a little bit of slop. Not bad. Let's go work on the crank arms. Let's do that. On the mill here, I've got my bronze bars. I have 2 bars. We're going to be making a crank arm like this. So we need to make 2 holes, and the holes intersect. That's how the cotter pin works. Which hole would you drill first? Would you drill the small hole first or the big hole first? Okay, I'll tell you what I'm going to do. I'm going to drill the small hole first, because when I drill the small hole first, I use a drill, which is a little, see, it's a little bit undersized. And then I take a reamer. Just fits. So it's 7/16 of an inch plus a thou and a half. So it's a little bit of clearance. So if I drill this hole first, that's what works best, because the second hole I drill down, I end up using a boring bar. This is a boring bar, and it goes inside. This is going to, if I drill the big hole first, this is going to flex into the big hole, and the reamer will flex a little bit too. It won't go straight because it goes into the big hole. So do the small hole first. When you're working on machinery and tooling, you always have to think of the sequence. It's important. I've got the center of the crank axle, or the bottom bracket axle, and now to make the hole for the cotter pin, I need to move it 460 thou. I'm going off the drawing here. There we go. Very small chips. Look at those little chips, and they're all curled like that. We have the intersection of the holes here. Can you see how it intersects? This turned out quite nicely. It took a while, but that's why you need patience when you're machining. Kind of hard to see, but I'm gonna do a little bit of hacksawing, and you'll see how hard this is to hacksaw. What I'm gonna do with the hacksaw, I'm just gonna cut it off like that. That's basically what I want to do. And then this morning, this is before you were here, I was here, and I made up this arbor. See what's going to happen? I'm going to hold this in the chuck on the rotary table, and then we're going to make that a beautiful radius, and then it'll get a little bit of sanding and polishing. So for now, let's go to the bandsaw. I was sanding the edges, and it caught. It actually threw this on the ground. So we're going to see if this is any faster now. I'll use this part of the belt. We'll just see if that's any faster than the hacksaw, because the hacksaw is pretty slow. See what happens here. Oops. Not that lever. This one. Okay. Going to take off the burr, or I'm going to make a little chamfer on each end, and then there's a little ridge there I'm going to file out. I think you can hear the hardness of the bronze when I'm filing it. It's kind of like it wants to skate on the top. So right here there's a tiny little ridge. So I'm going to dress that out so it blends in and it just looks like a perfect radius. And I'm just smoothing it out. It's called camouflaging. It's because the radius isn't 100% perfect, but it's very, very close. I'll use this mic. And it just blends it in, and then the eye can't even see it. That's what we want. So that when you look at it, it looks perfect. It's not exactly, but it's good for us. So that's it. That's how we make a set of bronze cranks for a 1894 Giraffe bike. Very good. Hope you've enjoyed watching this. Thanks for tuning in. Mitch and I like coffees. There'll be a part 2, obviously. Mitch and I like coffees. If you buy us coffees, that helps out a lot. Please like, subscribe, share. Take care. We'll see you next time.